Hello, math fans. Somebody's asking me on my channel if I could make a video about where 0 equals 1, which is funny. This happens from time to time. We'll be solving. We'll get 0 equals 1. And when I'm in lecture, I usually say math is wrong, class dismissed. I find that students enjoy when you get to 0 equals 1. They're hoping I'll squirm or something. They're like, ha ha, your whole life is a waste of time. But the thing is, you're probably right. So you can't get me. My quick comments are this. And I just tried to come up with a few quick examples. A common thing I see is people divide both sides by x plus 7. Just to give you an example. 0 over x plus 7. And they'll conclude, well, this is 1 and this is 0. 1 equals 0 and math is wrong. See if you can think of what the error was there. Now, a more practical example is this. I've seen this all the time where students divide both sides by x, and they get x minus 4 is 0, and x is 4, which is not completely the answer. And then here's the more extreme version. Divide both sides by x, and you get 1 equals 0. So there's the paradox in one step. These are all examples of division by 0. I mean, this one's the most explicit. You can't divide by x if it's 0. This is not valid. You also can't divide by x here if it's 0. Now, it's fine if x is 4, but if x were 0, what we just did is invalid. So there's two possibilities, either x equals 4 or x equals 0, which is the right way to proceed. That's why I say generally it's better to factor and solve rather than divide by x, is to avoid that. And then this is the same thing. We're dividing by 0. Okay, so there's a whole bunch of examples of that. Division by 0 does lead to 0 equals 1. Even the silliest case, if 0 equals 0, you divide both sides by 0, you get 1 equals 0. Why did I do 1 here and 0 there? Well, that's essentially exactly what we did here. Okay, I was trying to think about other cases, and so I just worked out a couple things. Then I'll do one calculus one to finish things out. So here we start with something that's true. We multiply both sides by a, so that's true. We subtract b squared from both sides, so that's true. I found this in an old book I had. We factored the left because it's the difference of squared. We factored the right. We canceled the a minus b from both sides, and we got this. We replaced a with b right here, because that's what we started with. And then we got 2b equals b, and so we get 2 equals 0. 2 equals 1, which isn't quite what you were asking about. Let's subtract 1 from both sides so we can get there. 1 equals 0, yay! So if I were with you right now, I would say, can you spot the error? Maybe you can put that in the comments. Where is the error there? And it's the same error we made up here. But sometimes in the middle of a calculation, you're more prone to make this error without noticing it. So impress your friends, 2 equals 1. I was trying to think of some other example of something similar. So I started with, what if you knew x was 2 and you squared both sides? And then you told your friends, you should remember that 4 is also negative 2 squared. And you said, well, x squared equals negative 2 squared means x is negative 2. And thus, 2 is equal to negative 2. I bet you didn't know that. So you might think about where I went wrong there. Where did I go wrong? And the thing is, when you square, you introduce two solutions, whereas initially there was only one. This is an error. This is one of the solutions to this, and it is true that x squared equals 4 has two solutions, but we started with one of them. So whenever you square both sides of an equation, you're introducing a second solution. So in general, when you're solving equations like that have square roots, you often have to check your final answer to see if you threw in an extraneous solution when you solved. This happens a lot in equations like this. I don't know, 2, where you get the square root by itself, and then you square both sides, which leads to two solutions, but when you go back, only one of the solutions actually works. Okay, lastly, this is in one of our worksheets. we have students do integration by parts on this. We do u is equal to, I'm just trying to remember the process, because this is the example. I should have prepared this a little better, but I think we do this for u. We do dv is dx. We take the derivative here, which is negative 1 over x squared. We integrate here, which is x. Okay, good. We smush these two things together, which is 1. We smush these two together, and it's minus the integral of negative 1 over x dx. And we get the integral of 1 over x dx is equal to 1 plus the integral of 1 over x dx. We subtract the integral from both sides, and you get 0 equals 1, and math is wrong again. This time calculus is wrong. Why did you take this course? And this is an exercise in constants of integration. Every time an integral appears, there's a constant. Not necessarily the same constant. So whatever integral you get from this, which would be log of x plus c1, is going to be, this will be log of x plus c2. And you can't assume that c1 and c2 are the same. And in this case, they aren't. Log of x plus c1 is 1 plus log of x plus c2. So the correct conclusion is that c1 is 1 plus c2 on the two sides. And if you throw in bounds, it becomes very clear what's happening. So there you go. There's a bunch of examples of 0 equals 1. Perhaps you can come up with more. If you find an example of something else where you get 0 equals 1, give me a link in the comments and I'll look into it. But there you go. Math is wrong. You've wasted your time watching this video and all my videos. Hope that's interesting.